Hi ladies and gentlemen, this is Mr. Green again. This is another in my series of lessons about geometry. We are in Unit 4 right at the moment. We're looking at circles and lines, and we're going to take up another topic in there just so that we can make certain we understand all the different concepts about circles and lines. Okay, don't forget, quiz corrections, make them if you need them. Due dates, things close, can't get back into them, so you need to make certain you got all the zeros taken care of before anything else, okay? Uh, Quiz corrections, you can always go out there and read the corrections drop box on the left hand side. It will tell you all about how to make corrections. Okay? So, what are we looking at today? We're looking at intersecting chords today. So, when two chords intersect, one place they could intersect is at the center of the circle. And if they did that, you would have central angles, and you would know that your angle would be equal to the arc would be equal to the angle at that point, right? Because they're central angles. But what if they don't intersect at the center? What if it's off center a little bit here? Well, if it were at the center, then the angles would be equal and the chords would be equal. And so using that information, we're able to say, if it's off center a little bit, we could just say add the two arcs together and divide by 2, and that's what the angles are going to be, because the angles are still going to be equal, aren't they? Because they're still vertical angles. And because they are vertical angles, mouse is not moving now, because these are vertical angles here, you can say those two angles are going to be equal to each other. Well, the arcs obviously are not equal to each other. So what they do is they add the two arcs together and divide by 2. And that gives you the measure of the angles. And the angles are the same. Interesting concept. Interesting way of going about doing that, okay? So we're going to try a couple of problems like that. Here I've got two chords that are intersecting each other. They're wanting to know what the measure of x is. Well, that's going to be obviously the measure of both the two angles here, right? Because the angles are going to be the same. So I'm going to add the two arcs together. 32 plus 10 is 42. I'm going to divide 42 by 2, and that's going to give me 21 degrees. That means these angles are both 21-degree angles. And if I pull this down, you'll see that that's what they come up with. Okay, so that's 21 degrees. That's easy enough to do. I think that's possible that we could do that. Let's try another one here. This one says if arc where's BC? BC is this arc going this direction. BC. It's 170 degrees. Okay? That's 170 degrees. They're giving me that. Okay? And arc AD is this arc going this way. Okay? That's 130 degrees. And they say find the measure of this angle, x. Well, we know that this angle is 20. That means we know that this arc is twice the angle, 40. We got that arc. That's easy enough to find, right? Well, guess what? We know that the circle is 360 degrees. And if I add 130, 170, and 40, what do I get? I get 340. That means 340 from 360. That means this arc must be 20 degrees out here. And the angle is going to be half of that arc, 10 degrees. Do you see how I worked through that to get that information? I added the 170 and the 130 divided by 2 got me 300 degrees. They got 300 degrees, right? 300 divided by 2 gave them 150 degrees. What is that? BEC. BEC. So they're saying that this angle in here is 150 degrees. Then they used the triangle theorem that says 150 plus 20 gave them that angle up there. Okay? So they did it a slightly different way than I did it. Doesn't mean it's the wrong way. It just means it's a slightly different way, doesn't it? But I used an inscribed angle to find mine, getting this 40 degrees up here, and got the same number that they did. I got 10 degrees for my angle. Does everyone see how that can be done? A couple different ways of doing that. Interesting. Okay? So what happens when the chords intersect outside the circle? Well, wait a second, that makes them secants, doesn't it? Because now they're not just line segments, they're having to be a line going through here. That's a secant, and that's a tangent. A secant and a tangent here, right? Well, what they're telling you here is that if you take the arc AD, this one over here, and subtract this one over here from it, and divide by 2, that's what the angle, this measure this angle is going to be. So we're going to subtract them this time because they're outside. We added when they were inside. We're subtracting when they're outside. That's interesting, okay? So let's look at this. 190, 50, 190 minus 50 is 140. 140 divided by 2 is 70. So I'm saying that the angle B there is 70 degrees. And that's exactly what they worked it out to be. Okay? So we're adding on the inside, subtracting on the outside. It seems like an easy way for us to remember that. Okay? So I do appreciate you guys letting me know that what course you're in when you send me information, what section of the course you're in. It helps me find your information and respond to your questions a whole lot quicker. Thank you, and I'll talk to you next time.